Welcome everyone who's just started watching this broadcast. And if you want to join in person, feel free to do. There are a few extra slots left on the Hangout. And there's a total of 10, so if you try to join and can't manage it, you can still just watch the broadcast. So let me introduce Papi, otherwise known as Johan, who's an App Engine DevRel who's been doing a lot of work with Go, the language Go. And this is Andrew, another App Engine DevRel, and this is Dave, who works on Go, and my name's Amy. And Papi's going to give a presentation about building Go apps on App Engine, and we want this to be as interactive as possible. So those of you we encourage a few of you to join the Hangout if you feel like it and ask questions as we go along. And if you know the Go IRC channel, I think someone's monitoring questions on that as well.
And in the App Engine IRC
channel. And on the App
well.
Engine IRC channel also. All right, great. So let's get started.
Okay. So it's a short presentation explaining you how to build a simple application with Go on App Engine. You can follow the slide along on copy-go-ae.appspot.com. So a bit of presentation about me. My name is Johan Afrozin. I'm working Google Zurich. I'm a developer program engineer on App Engine, which means that I'm supporting the App Engine developer community on the forums, on Stack Overflow, and also on IRC. I write code sample for new feature when there is a new SDK release, and I write articles about best practices. You can reach me through my Google Plus profile, profiles.google.com/profile. And here is a photo of me with more hair. So what is App Engine? So quickly, App Engine allows you to scale your web application by running them on Google infrastructure. So you get to use the same backend as Gmail, Calendar, and other Google properties exposed as API for your application. So, and recently, last year, we announced the Go runtime as experimental. So the Go runtime has a few unique properties compared to the other runtime of App Engine, which are Python and Java. So it runs native code. It has a very low memory footprint, meaning that Go instance on App Engine usually consume less memory than other instances. It's also faster to start because since it's all compiled to a single binary, when App Engine starts your application, it only has to read a single file, whereas with Java or Python, it has to read multiple Java or multiple Python files in order to start your application. And also there is built-in support for concurrency. By default, what happens when you deploy a Go application on App Engine is that it spawns a Go routine, which is a lightweight thread on each request. And when one request is doing some I/O, it can process another incoming request. Meaning that you get to consume less instance hours because your instance is more used as there is more requests coming in. The runtime doesn't necessarily need to spawn new instance for handling more requests. So I read a simple example of how to write a web application in Go. So we just import a few packages. So we'll import the thumbed package for formatting string and the standard net HTTP package, which allow you to configure an HTTP server. There is an init function which is called when your application starts, and in this init function we just define a route to a URL which is called hello, and we map it to a handler which is a function hello. And then in this function, which takes two arguments, a response writer to write our response and an HTTP request just to get the request parameter, we can write to the response writer just the text that we want to write to the browser. In order to deploy it to App Engine, we need to create a small manifest. which will describe our application. So we named our application. Its name is Gopher. We tell which runtime we want to use. We want to use Go. We define some handler for static files. So since there is if we want images, for example, served by your application, we just define a path images that will serve all the files which are located in the directory images. Same for doc. And then we just map all URL to our Go application. We can start an experiment with the application locally by starting the development server, which is built in the Go SDK. And if we want to deploy it to App Engine, we call app-cfg update, and we give it the path of the application. It will upload it to App Engine. So
and probably let me interrupt for just a second to encourage. We still have a few open Hangout slots. So if anyone wants to ask any questions, please do join. And welcome to Marcel, who just joined.
Welcome. So yeah, here is a small demo of the application we just created. So it just prints a Gopher to the stream. So now we'll try to do a bit more complicated thing. So I don't know if you are reading the news like me, but I always end up checking both Hacker News and Programming Reddit at the same time. So we'll write a small application that will allow us to check both at the same time without opening two browser windows. So what basically our application will be doing is that it will fetch the JSON and XML stream of both Hacker News and Programming Reddit and print it to the screen and serve it as a text file. So first, in order to be able to fetch the Hacker News stream, we will import a module which is called App Engine URL Fetch, it's an API on App Engine that allows us to fetch remote HTTP resources. We will import encoding XML since Hacker News RSS feed is encoded in XML. We define a new handler which is called Hacker News, and we bind it to the function Hacker News. And so here is how we can decode XML in Go. So you can see here the structure of the RSS feed of Hacker News. So there is a root element which is called RSS, then a child element which is called channel, and for each item in this channel there is a child item which is called item, and with both a title and a link tag. So we need to define some type that will map to this XML structure. So to do that, we just define plain structure in Go. So the way you define structure in Go is just that you create a new type declaration, you give it a name, and then you specify the member of your structure. There is so here, for example, we'll just define a structure for the root element, and we said that a feed has one data element, which is called channel. So here we have a small annotation that allows us to bind or struct elements to the name of the tag in the XML stream. So, and what is a feed data? A feed data is a channel, so it's a collection of XML items. So here we just have a slice of item, and each item is a title, which is bound to the title tag, and a URL, which is bound to the link tag. And so here we have no hierarchy, a structure hierarchy, which completely maps to our RSS feed format. And the way we decode that in Go is quite simple, actually. So we create a new function which is called Hacker News item, which will take an App Engine context. So an App Engine context is what is necessary to issue App Engine API call and return a collection of items that we just defined on the previous slide. So we just create a new URL fetch client that will allow us to make HTTP requests. We issue a GET request to the feed URL, which is serving the RSS feed for Hacker News. We handle the error, so we print an error in case we don't manage to fetch a string. When we issue a GET request, we get a response back. A response, we can read the response with the body member, and we have to make sure that we close the body before our function ends. And for that, in Go, you have a very useful keyword, which is called defer, which allows you to specify a function call on the right that will get executed when your function exits. So whatever exit point that you have in your function, if you return in the middle of your function, or if you just go through the function till the end, this statement will get executed. So that line ensures that we close the body before the function exits. And we create a new decoder in order to decode XML from the body. And we just instantiate the root type that we defined on the slide before, which is the root element of our hierarchy of type for defining the RSS feed, and we call the decode function. And what the decode function will do is that it will parse the XML stream and instantiate all elements on the fly that correspond to the type that we have given as an argument. So where it will go on the RSS element, root element, it will instantiate a HNFeed object. And then when you will see a channel element, it will instantiate a HNFeed data structure. And while you will see item element, it will instantiate a new item object for each item that it encounters. And so after that, we just have to return the data item that we just parsed. And so the last thing that we need to do is to print into back to the browser that issues the request to us. So we just set a content type to say it's plain text, and we just iterate on the objects that we get back from the Hacker News item function. Here you can see how to make for loop in Go. So there is a range keyword that will return both an index and an item. For each item that we get back for the Hacker News item function, we will execute that statement, which will just print each item title and each item URL. So here we can see a little demo. So here we can see all the links, so the title and the URL of each item that is in the Hacker News RSS feed. So does anyone ask a question?
Proppy,
yeah.
On the previous slide, what was the underscore in that range statement?
So good question, Ango. So the underscore is to say that we don't want to use this parameter. So it just binds the parameter. Since we have to explicitly say that we want to handle this parameter in Go, it's pretty tight. So as a range keyword will return 2 items for each iteration, we have to say that we don't want to handle this parameter. So it's just a wildcard to say that we don't want to handle this parameter.
So if I did have a variable there, it would be assigned the index of each
element? So the range will return both each index and each element of the collection that is on the right.
So I have a question for you, Proppy. So this code all looks pretty clean. So how would you, with what you've shown so far, what about it do you think is maybe easier than writing in Python, or what maybe is harder? How would you want to comment on that, or would you maybe want to wait until you show a little more code?
I don't think he's good part yet.
Okay.
Yeah, so that's an interesting question. So in Python, that you have some modules that allow you to decode XML on the fly and map it to objects. But usually what you get back from that is a dictionary, because you can't. The only generic types that Python could use without knowing it, knowing what you want to decode, is just plain dictionary. And so what happens is that you've got the same convenience as Python for decoding arbitrary XML structure, but you also get type safety because you define exactly what you want to decode, and it maps to concrete type that you have defined in your application. Whereas in Python, what you will get with similar, it will not be more complicated, but it will be less typed, because what you will get back from a generic decode XML function will be just a Python dictionary. Whereas in Go, you get like concrete types that you have defined.
Mm-hmm.
So does that mean that when you're using the Python dictionary, you would need to test for the presence of various keys? Whereas in Go, the data types, because the fields are always present in values of those types, you don't need to do all that.
So it guides you, basically it's allow you to address elements in the XML and be sure that they are there. Whereas in Python, you are not sure of what is in the dictionary in advance. Because
just as a Go novice, that's one thing I like about it: the strict typing, but the easy definition. So it doesn't have all the syntactic overhead of something like Java.
I find it very convenient that you can parse an XML in a single line and just annotate your type, just with simple annotation binding a field to struct field to XML elements. I find it very there is no syntax overhead for something which is not trivial. I mean, like data binding is not a trivial operation, and I find that the solution that Go use is very convenient.
There's also one other nice thing about it, which is that the XML decoder will only decode and store those fields that you actually have present in your Go data type. So if you're decoding a really large XML stream, you won't have to load all that stuff into memory before discarding it again. You can just only take out the fields that you're actually interested in.
Yeah, whereas you're right, whereas a Python generic decode function will decode all the fields. Don't give you any... you will have to manually iterate through... I mean, either you do the parsing yourself using some kind of reader, and then you can selectively get what you want, but then your parsing code is very verbose. Or if you use a generic decode function, you will just get an enormous dict if you have an enormous string. Yeah.
But as Andrew said, I suspect you're getting to the really cool stuff in just a minute here. So.
Actually, it's just the same with JSON. So, no, we'll do exactly the same with programming Reddit. And so Reddit API serve a JSON file. So, and actually it serves both a RSS file and some JSON file, but the RSS file structure is quite messed up. So you can't access the link of element because it's encoded as a C data inside the description. So for being able to easily parse title and links in programmatically of programming Reddit, you need to use the JSON API. And for that, we'll just import encoded JSON, just like we import encoded XML before. We'll define a new handler, which is called proget, to handle the URL/proget. And we will map JSON to Go type, just like we've done before with XML. So the structure of the JSON feed is a bit complicated for what it is, but it's like this. So you've got a data element which maps on, which has a collection of children elements, which has a children attribute with a collection of children elements. Each of these children elements also have a data attribute, which finally have the title and the URL. And so we'll just define Go type just as before. So a Reddit feed is a data element. And so you see here that we don't have any annotation, because what happens in Go is that if you don't define an annotation, the decode function will default on parsing the attributes that correspond to your property name. So here it will know that it needs to get the data attributes because we've defined a property in your structure which is named data. So a Reddit feed data is a collection of items, and so we have a Reddit feed item type, which is which will map to the JSON children attribute. And so here you can see that we have put an annotation because the name of a property is different from the name of the attribute. And then each Reddit feed item will be a data item. So here, just to capture what is in the attribute data. And the item structure will just be the same structure that we have been using before for decoding XML. So here you see that you have two hierarchy of type that use the same leaf type element, which is item. So we will be able to decode Hacker News and programming Reddit using two different functions, and we will get item the same item type back from the decode function. So here is how we decode our JSON stream in Go. So it's quite similar to what we've seen before with XML. The only difference is that we instantiate a new JSON decoder instead of instantiating an XML decoder. We use the Reddit feed type instead of using the Hacker News feed type. We call decode. In order to return a collection of items, we have to iterate, because what we get back from the decode function is a Reddit feed, which is a Reddit feed data, which is a collection of Reddit feed items. And what the function return is a collection of items. So we need to instantiate a collection of items. So you do that in Go by using the make keyword, which allows you to instantiate a slice of item, and you can specify a length and a capacity. Here we know the length in advance, so we can say that we want to instantiate as many items that we have Reddit feed item in our Reddit feed data. And so we just iterate on all the items and fill the new slice that we have just created. And so in the end, we get a slice of item back from this function. What's left is just that we need to print it. So as before, we just set the content type header, iterate on what we get back from the proget item function, and print it to the response. And so here you can see that we just printed the items that are the top items that are in programming Reddit, the title and the URL on the right.
And Poppy, just
yeah.
Since people might not be able to see that output very well and just might be interested in general, I think that you have the code also on code.google somewhere, don't you?
Yeah, it's in the end. At the end of the presentation, there will be a link to the code.
Okay, great.
So yeah, so now we need to print both, because we are printing Hacker News item, programming Reddit item, and now we want to print both on a response. And so since we can just like call our Hacker News item function, call our proget item function, get the item back, and just iterate of each of them and print them to the response. And so we'll first print the Hacker News item and then print the programming Reddit item. And here you can see that we actually printed both. And you can see we can have some I added some log statement in the code before in order to check the latency. So we see that it took like 200 milliseconds, 260 milliseconds to fetch the item from Hacker News. It took like 100 milliseconds to fetch the item from Proget. And to print both of them, like the latency of the caller function, which was Proginator, is just the sum of the latency of Hacker News and Proget. So it means that if Hacker News is slow, like we won't be able to print anything before Hacker News has ended. And also we'll just like sum the two latency of both URL fetch. And so what we need to do in order to be more efficient is to make it concurrent. So it's just like the same code that we've seen before. We just added a few keywords. So we are using the Go keyword, which will spawn a Go routine, which is a lightweight thread. It will allow us to fetch hacker news item and programming Reddit item concurrently. So here we just, and in order to get the item back from this Go routine, we'll create a channel. So we create a channel. A channel is a structure that will allow us, that allow Go routine to communicate safely between them. So you post just regular Go type to a channel, and you can send item to a channel and read item back. And what we will do here is that we spawn two Go routines that will each send a slice of item to the channel. In the parent Go routine that has been spawned to handle our HTTP request, we just read item back from the channel. So it means that both URL fetch will concurrently happen. So here we just create a new channel which will contain item slice elements. Here we spawn the Go routine and send the result, which is a slice of item, back to the channel. Here we spawn another Go routine for programming Reddit and send the result back to the channel. And here we iterate we do an iteration of two, because we have two elements to read from the channel. Read them. So this is a receive syntax for receiving stuff from the channel. And then we iterate of each on the slice that we get back from the channel and put them to the stream. And here you can see exactly the same result as before, unless that it's just quicker, because here are the latencies. So programming Reddit take 110 seconds, hacker news take 190 seconds. The prognator function only takes the highest latencies of the two. So it means that both URL fetch call happen concurrently. And since they happen concurrently, we are only bound to the slowest one, instead of being bound to the sum of the two latency. So there is some takeaway from the talk. So the encoding package makes parsing fun again. So we see that it's really easy to bind Go native type to either XML elements or JSON attributes, which make parsing really easy and instead of the core. We have seen that the Go runtime is inherently concurrent, so you can easily spawn Go routine and make sure that to handle I/O operation concurrently, and also the Go runtime will spawn a Go routine on each incoming HTTP request. And we've seen also that there is no need in Python, in Java, in order to do the same thing and to achieve the same speed up, we would have to use an async API. And here we've seen that in Go we don't need to have async and seek version of our API. We just add a Go, we just wrap the code that we want to be async with the Go keyword, and just use the channel to get the result back, and it turns a synchronous API call into something asynchronous. And so there is some homework that you can do in order to improve this this demo. So you can obviously the same stuff get often sent to both Hacker News and Programming Reddit. So you can write some code to deduplicate and sort by ranking. You can make it pretty because it's just plain text right now. So you can make it prettier with templates and CSS. You can move the fetch to happen offline instead of happening on each user request. So instead of doing a URL fetch on each incoming HTTP request, you can spawn a task queue that will do the URL fetch in the background and cache it. So when you have like thousands of people visiting the site, you don't do a URL fetch to exactly fetch the same content to Reddit and Hacker News each time. You can go fork the messy code at this URL, so code.google.com Progenitor project. And the slides are also available in this repository. So thank you. There is some links that you could investigate if you want to go further. So there is this is a doc for the Go App Engine runtime. This is the main website for the Go programming language, and there is my profile on Google+. So if you have any question, we can go now.
Robin, can you hear me?
Yeah.
Yeah. At the just a quick question. If you're using this, if you're passing directly the channel, just the items that when you collecting the item concurrently.
Yeah.
You would be passing directly the channel into the template, or collect the item and then passing them to the template.
Sorry, I couldn't really hear the question. Can you try to do it more slowly? Or just type in the chat?
I'm in the chat.
Yeah, just type in the chat. It will be simpler.
Yeah, I can read it out if you like.
So the question is, if you were using templates, would you pass channel directly to the template or collecting items and passing those to the template? So I think I will do the latter. So what I will do is that I will, because what I get back from the channel is not actually the individual item, that I get a slice of item from the channel. So what I will do is, in the main Go routine, I will collect the item from the channel, the slice of item to the channel, and just render my template by giving it the slice of item as an argument. But maybe Andrew has a different perspective on this.
With the way it's currently designed, then yeah, you probably would do that. But it is possible from within a template to range over a channel in the same way that you can range over a channel in normal Go code. And that's particularly useful if you have some code that's generating values and like a large stream of them, and then you want to generate a particularly large template. You can have your generator and your template being, you can have the values being generated and the template being constructed concurrently without having to load your entire data set into memory, which is a really nice property. But in this particular instance, you're already loading all of the items into memory immediately when you do the JSON and XML decodes. So there's no real advantage to streaming them into the template itself. You might as well just collect them and arrange them before passing them into the template, and that's what I would do usually as well.
Yeah, but also when we pass the item, the slice in the channel, it doesn't copy the individual elements. Like it's just a reference to the same slice. Right?
Yeah.
So we don't duplicating the slice content in multiple Go routines. So
Yeah. Well,
yeah.
Sorry, go on.
Yeah, no, go on. Sorry.
I was going to say, in this case, are the items, are they values or are they pointers to items? It looks like they're items themselves.
Yeah, they're items themselves. But when you pass it to a channel, my understanding is that when you emit a slice of item to a channel, you don't copy the individual elements, right?
Yeah, that's correct. I mean, when you pass a slice around, you're passing a reference to the underlying data. Yeah. But if you wanted to, say, sort or deduplicate those items and sort of interleave the ones from Progit and the ones from App and Use together, then you might consider using a pointer type, so a slice of pointers to items instead of a slice of items, and you'd have some small saving there. But the actual item struct is very small because it consists of some string values, and string values in Go are reference types as well. And so there's very, very little copying going on there. I mean, each item is probably only about, I don't know, 64 bytes or something.
So I will quickly, I will take a look if there is any question on Google Plus or on the Dory.
Okay, and I have a question for you, Profi, if there are no other questions. Why don't you take a quick look first?
Well, there is one question on the moderator, which is an App Engine question. And it's from Jurka Danjik from Czech Republic, saying, I don't want my app to depend on App Engine too much. I'm afraid of the vendor lock-in issue. How hard is it to build an app in Go that runs on App Engine, and if needed, can be moved to my private web server?
So I think that actually David can comment about this, because he recently implemented something in the Go builder that helped with it. I mean,
it'd be pretty easy to write a Go App Engine app that has minimal dependencies on App Engine itself. For example, the Go website itself, golang.org, is powered by an App Engine app, but that App Engine app is almost completely just GoDoc, which is a standard Go program that you can build and compile and run on your own machine, and ships with a standard Go distribution. All that has is a very small little wrapper file that a substitute for its main, and other than that, it's just a regular web server. So the design of the Go runtime on App Engine is pretty permissive for allowing you to write something that's independent of App Engine.
So if you wanted to write an app like this, this is actually very portable because the HTTP package is well integrated with Go and App Engine. So, like Dev just said, if you write just a straight web app that doesn't really talk to much of App Engine, you can basically just use one in one place or the other. The one about API that we're using here is URL fetch. And if you look at this, is it on this slide? Or Profi, can you go to a slide which has the creating a URL fetch client on it? I think that had it. So if you notice on the first line of this function after the declaration, the URL fetch client, that variable client is actually just an HTTP client, the same type of HTTP client that you would use in a standalone Go program as well. So the URL fetch client just implements the same interfaces, and you can use anything that expects those interfaces, which is basically any Go package that uses HTTP. So we've tried really hard in creating all of the Go App Engine APIs to use a lot of the standard Go interfaces, so that it's really easy to use the Go standard library and external libraries with the App Engine APIs, and also to decouple your app entirely from App Engine. With that said, if you write an App Engine app that depends heavily on the task queue infrastructure and the App Engine data store, those are really, really rich APIs, and that's one of the real value adds of the App Engine platform, is that you get these really, really scalable, reliable systems that you don't get for free, and it would be a little bit more difficult to divorce yourself from that.
Yeah, it's interesting to note that there is a project called AppScale that does implement the Go runtime. So it allows you to run basically API stubs that map to regular database or workflow software that will just provide you the same SPI that you have on App Engine, but with different backends that use like MongoDB or RabbitMQ for the task, things like this. And also, I wanted to maybe David, can you tell us a bit about the build tag and the App Engine build tag? Because I think that you can easily design your app so you have the App Engine specific parts that are identified as with the App Engine build tag, and so you can still use the regular Go build tool to build your stuff without the App Engine specifics, right?
Not entirely sure what you're asking. You can write your own places that you fill in with an implementation that uses the App Engine APIs. And
no, I was thinking, like, for example, Andrew was saying that the URL fetch module uses the same interface as the regular HTTP client.
Yeah.
Module.
Well, this code you've got on your slide is a great example.
If you write your App Engine specific code and just annotate it with the App Engine build tag, can you make sure that the Go tool, when it builds your application, doesn't build the bits that are specific to App Engine?
Yeah. So just in the same way as you could say, write some code that depended on some platform-dependent feature. So you had some code that would only work on Linux, or some code that would only work on Mac, or some code that would only work on Windows. You can add a little annotation at the top of your source files, and the Go tool will only build those when it's on that platform. The same thing with App Engine. So if you have a build tag at the top of your file that says this file requires App Engine, or App Engine apps, or App Engine apps, what use the file.
Okay, so yeah, I think that it needs that there is like support built into the Go tool in order to build web applications that can span more than one platform.
Yeah.
So let me ask you a question, Poppy, and this is also directed to Andrew and Dave, if you want to answer it. So the Go routines and channels are really cool, and it's sort of a philosophical departure from what people might be used to as, or might think of as sort of regular thread programming, if you're a Java programmer. And it seems like it lends itself less to getting into trouble with that kind of programming. Maybe you want to comment a little more on that.
Well, I mean, if you consider Proppy's example of performing these two calls in parallel and then having a rendezvous and collecting the results, using a traditional kind of semaphore approach, you would probably use like a wait group or something like that. Generally, there's just a lot more boilerplate involved in setting up the channels and setting up the locks, and then it can be a lot more. Basically, what you're doing is you're talking around the problem. You're creating this kind of signal.
So it seems that they are just freeze for me. Is it the same for? Okay, so you were freeze. You were frozen. So.
Yeah, we're back, but I think we need to start over with what Andrew was saying.
In essence, what I'm saying is that in Go, to make something run in another thread is 3 characters still in a space. In pretty much any other traditional threading environment, there's a lot more involved in setting up a thread. And similarly, to communicate between threads, in a traditional sort of method, you have some sort of semaphore, like a lock, and then you have the data that you want to communicate, and they're 2 separate things. In Go, they're combined into the same thing. You have a channel, and the channel is both a signal. it's synchronization, and it is the message itself, it's the data. And so it's a lot less error prone, particularly once the system becomes more complex. And so I think it's a pretty clear win if you're building any kind of concurrent software.
Yeah, one of the mantra of the Go concurrency model is don't communicate by sharing, but share by communicating. And so I think that's also really useful. I mean, the way the App Engine, maybe David can correct me, but the way the App Engine runtime is designed is that it will spawn one go-routing for each incoming HTTP request. It will not allow you to run, it will not run more than one go-routing at a time, but if one go-routing is doing I/O, it can yield execution to another go-routing. And since most of what App Engine app are doing is doing RPC call and API call, so that's really a strong win for App Engine because it allows you to, even if being single-threaded, it allows you to run many operations concurrently.
Yeah. And Go is easily the most lightweight of the three App Engine runtimes as well. So in terms of squeezing CPU time out of your instances, I think it's pretty good for that too. Does anybody else that's in the Hangout have questions that they'd like to ask about the talk or about App Engine or about Go? Are you
still on the IRC
Yeah,
channel?
I've muted a few people, so maybe I can unmute them. Yeah, so does anybody ask questions? No?
There's Chris.
No, Chris is here. Hey, Chris.
Do you have any questions about Go, Chris?
I do.
There's the microphone.
His mic is broken, so we'll ask the question in chat. We say I like the example where multiple results come from Hacker News and Reddit at the same time. Is it possible to run a data store queries concurrently?
Yes. Very easy.
Yeah, you just have to wrap your API call into Go routine and run concurrently.
Yeah, in essence, yeah. But with the data store, though, you have to be aware that it won't necessarily buy you a lot. It depends what you're doing, particularly if you're doing transactions within entity groups. If you try and conduct 2 transactions on the same data at the same time, or even on data that's in the same entity group, then you're going to you probably won't see a big win over just doing it sequentially, because instead of serializing it in the client, it'll just be serializing it inside the data store.
Yeah. You could do it concurrently with a URL fetch. So you're rendering a blog, you could be fetching your blog post from data store at the same time as doing a URL fetch to say a weather service, because you know the weather in Sydney, probably a blog, or whatever it is. You could be doing all that at once very easily.
Yeah. I don't know about the specific of the the way the data store, the small data store API layer does API call behind the hood, but I know that for Python, maybe David can confirm, but I know for Python when you are doing a multi-get on multiple keys, it will actually do multiple parallel RPC for each entity group. I don't know if it's doing the same for Go, but you have to realize that that can be an extra level of concurrency that sometimes is introduced on the library layer, so on the SDK layer. So for for you, it can look like just an API call, but behind the hood, it can spawn multiple async call. And also, there is another layer of concurrency happening on the server side. So when the data store backend receives your request, it can decide to go and fetch result concurrently as well.
Yep.
We have someone typing in the chat window. In app.yaml for Go runtime, you specify script underscore Go app as the
It's the main handler.
Yeah.
So what is the magic behind that? So essentially, when we designed the Go App Engine SDK, we based it on the Python SDK, and so the Python SDK uses an app.yaml file to define handlers. And in Python land, you actually specify the handler, and then you have a script directive that says which Python script is actually going to handle this request. But in Go, we don't run multiple Go programs for multiple requests. We just run a single instance of your Go app, and then all of the HTTP requests that are to be handled by the Go app are sent to that single app, no matter how many handlers you have defined. So the script colon underscore Go underscore app, it signifies that this is a handler that should be handled by the app. And so you can't have separate Go apps that handle different parts of your app. But you can just write totally independent packages that handle various handlers independently, and they can effectively be independent programs. But on the server side, you must understand that they're actually built into the same binary and they're executed together. So it's a slight departure from the way it works in Python.
Yeah, I think that you can you handle most of the routing actually in your Go application, as opposed in Python, where you handle some of the routing in app.yaml and some of the routing in your Python application. Here, it's actually cleaner design because you actually only have one place to put your dynamic routing, whereas in Python you can decide to put them in two places. And that's actually sometimes it's confusing for users as well. I would add another thing to what Andrew says is that you can have backends that are a different Go app that interact somehow with your Go application with task-queue. So if you need to, with the same application namespace, if you need to deploy multiple Go programs, you can either use version or you can use backend. That allow you to deploy different binary to the same application.
And also, if you have a Python application and you want to use Go to do something that you can't do in Python, like if you have some number crunching or something, you can actually deploy a Go backend to your Python app and communicate between the two using task queues, which is actually a pretty powerful combination. You could do the same with Python, with Java as well.
Yeah.
But Alex also asked if he can have multiple handlers, and the answer is yeah, you can have multiple handlers. But the point that Proppy was making is that your app YAML can basically just have a catch-all expression in the handler and then hand off all of the routing of requests to the Go app itself. So you just have your handle clauses in the Go app handling the paths that you want to serve.
In fact, Poppy's example from the talk has at least 3 handlers.
So, any more questions? Otherwise, I guess we can wrap up.
Oh, to an actual binary, yeah.
Yeah, it is.
Binary. So Alex says that he got it like we are compiling the app to a sort of binary, but that's actually a binary.
Yeah, it's the real program that runs at native speed.
And so that has also another nice side effect is that it's really fast to load. So the Go instance startup time is really one of the fastest of all the App Engine runtime because it only need to read a single file in order to start your application.
Yeah, and so in contrast to Python, which has to actually interpret your Python code and fire up a Python interpreter, or the the JVM, which actually has to load a JVM. And so if your app sees a sudden spike of traffic, a Go app can respond really, really quickly because it takes, probably hundredths of a second to fire up a Go app. It really is pretty impressive.
Yeah, I have a question for David. And so I was wondering if there was so you know that when you start a Go routine on App Engine, you can only do useful things in the window of the request. So if you are outside of the request window, you can't really interact with the API. You can still have a Go routine running in your background in your application, but they won't be able to issue any API code, right?
Right. Yep.
And so I was wondering if there is support for. Recently, in the Python and Java runtime, there was a new concept introduced, which is called background thread, that allow you to spawn threads that span across the request window. So you can, but it's only for backend. And I was wondering if there is the same thing which is planned with Go. So to allow you to spawn Go routines that can interact with the API without tied to an HTTP request.
Yeah. So there's two modes of operations for backends. There's a serving backend, which just serves requests. A request will come in, it'll handle it, it'll return a response, and then finish up that request. But there's also, I don't know the terminology, long-lived backends or processing backends. And in that case, what happens is that the Go instance will start, and the App Engine infrastructure will send it a request to URL looking like something like _AH/start. Now, if the backend doesn't return from that, then that backend is treated as a long-running processing backend, which means that you have effectively a long-running request that can last for minutes, hours, days, weeks. And so during that time, you can make API calls if you construct an App Engine.context from that request that you received to _AH/start. So in effect, you get the same thing where you can have something long-running for a long time, but making API calls.
So you just have to construct the context when you get the warm-up, and just reuse the same context all over.
Yeah, and not return from that initial request.
Okay.
Yeah.
Yeah, in effect, that becomes your main. Like if you're writing a standalone function, then that start handler is just like your main function.
Yeah.
Yeah, and if this serving backend is doing I/O, if this long-running backend is doing I/O, for example, like it's blocking on a channel or like blocking on the API call, does it mean that it can handle incoming HTTP requests as well?
No. If a backend doesn't return from the AH start request, then it won't be sending any more requests. So
Okay.
It won't be doing in that respect.
Okay.
Yep.
Okay, well, I think we're at the top of the hour, so as they say in radio. So yes, we have no more last-minute questions. Thanks everyone very much for joining us or for watching.
And thanks, Proppy, for writing and delivering the talk.
Thanks very much, Poppy. Yeah, see you guys next time.